Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 6 to the power of x is equal to 60. So the first thing I'm going to do is I'm going to rewrite 60 as 6 times 10. So now I have 6 to the power of x is equal to 6 times 10. Now, I'm going to go ahead and divide both sides by 6. So then these two cancel out. Now I'm left with 6 to the power of x over 6 is equal to 10. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, 6 is the same thing as 6 to the power of 1. So I have 6 to the power of x over 6 to the power of 1, and if you divide these two, you get 6 to the power of x minus 1 is equal to 10. Now, if I take the log on both sides, I have log 6 to the power of x minus 1 is equal to log 10. So an important property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, log 6 to the power of x minus 1, I can move x minus 1 to the front. So this is going to equal x minus 1 times log 6, which is equal to log 10. Now, if I divide both sides by log 6, these two cancel out. And now I'm left with x minus 1 is equal to log 10 over log 6. Now I'm going to go ahead and add 1 on both sides. So these two cancel out. Now I'm left with x is equal to log 10 over log 6 plus 1. Now log 10, this is the same thing as 1. So now I have x is equal to 1 over log 6 plus 1. So log 6, this is equal to 0.7782. So if I replace 0.7782 with log 6, I get x equals 1 over 0.7782 plus 1. Now 1 over 0.7782, that's 1.2850 plus 1. And this is equal to 2.2850. So this is my answer. Alright, so I have 5 to the power of x plus 2 is equal to 4 to the power of x. So the first thing I'm going to do is I'm going to take the ln on both sides, or natural log. So now I have ln 5 to the power of x plus 2 is equal to ln 4 to the power of x. Now, if I have something in the form ln a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times ln a. So for ln 5 to the power of x plus 2, I can move x plus 2 to the front. So that's going to equal x plus 2 times ln 5, which is equal to, for ln 4 to the power of x, I can move x to the front. So it's going to be x times ln 4. Now, if I distribute ln 5 with x plus 2, I get x times ln 5 plus 2 times ln 5 is equal to x times ln 4. Now, I'm going to subtract both sides by x times ln 4. So now I have x times ln 5 minus x times ln 4 plus 2 times ln 5 is equal to 0. Now, if I subtract 2 times ln 5 on both sides, these two cancel out. Now I'm left with x times ln 5 minus x times ln 4 is equal to negative 2 times ln 5. So now if I factor out x from x times ln 5 minus x times ln 4, I get x times ln 5 minus ln 4 is equal to negative 2 times ln 5. Now, if I have something in the form ln A minus ln B, this is the same thing as ln A over B. So ln 5 minus ln 4, that's going to equal ln 5 over 4. So I have this is equal to negative 2 times ln 5. Now I can move this negative 2 to the front of the 5. So now I have x times ln 5 over 4 is equal to ln 5 to the power of negative 2. Now 5 to the power of negative 2, that's the same thing as 1 over 25. So now this is equal to ln 1 over 25. Now if I divide both sides by ln 5 over 4, these two cancel out, and now I'm left with x is equal to ln 1 over 25 over ln 5 over 4. So this is my answer. Alright, so I have x to the power of x to the power of 6 is equal to 144. So I want to find the value of x. So to start, I'm going to take the power of 6 on both sides. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n, these two are interchangeable, meaning this is the same thing as a to the power of n times m. So now, if a to the power of m times n is the same thing as a to the power of m to the power of n, then a to the power of n times m, this has to equal a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, we have x to the power of x to the power of 6 to the power of 6. We can think of x to the power of 6 as m and 6 as n. So now we can switch these two places. So now we have x to the power of 6 to the power of x to the power of 6. Now this is equal to 144 to the power of 6. Now I'm going to let x to the power of 6 equal the variable y. So now I have y to the power of y is equal to 144 to the power of 6. Now 144, this is the same thing as 12 to the power of 2. So now I have 12 to the power of 2 to the power of 6. And remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 times 6 is 12, so I have y to the power of y is equal to 12 to the power of 12. Now if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, y is equal to 12. However, remember, we're not solving for y, we're solving for x. And x to the power of 6 equals y. So now that we know that y is 12, this means that x to the power of 6 is equal to 12. So now, to solve this, I'm going to take the power of 1 over 6 on both sides. So now I have x to the power of 6 to the power of 1 over 6 is equal to 12 to the power of 1 over 6. Now 6 times 1 over 6, these two cancel out. So now I'm left with x is equal to 12 to the power of 1 over 6. So this is my answer. Alright, so in this video, I'm going to solve the equation x to the power of x to the power of 4 is equal to 64. So the variable I want to find the value to in this equation is x. And for my solution, I'm going to first start by taking the power of 4 on both sides. So I get x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. However, m and n are interchangeable, meaning this can also be written as a to the power of n to the times m. Now, if a to the power of m times n is equal to a to the power of m to the power of n, then a to the power of n times m, this should be equal to a to the power of n to the power of m. So x to the power of x to the power of 4 to the power of 4. In this, I can think of x to the power of 4 as m and 4 as n. So this turns into x to the power of 4 to the power of x to the power of 4 is equal to 64 to the power of 4. Now 64 to the power of 4 I can rewrite as 8 squared to the power of 4, which turns into 8 to the power of 8. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a equals b. So in this case, x to the power of 4 is equal to 8. And to solve for x, I'm going to take the fourth root on both sides. So I get x is equal to positive or negative fourth root of 8.